Welcome to day 5. So if you've been struggling to see the vision and have been itching to see this thing work, we're over halfway through our 7 days and things are going to start moving fast from here. Today we're focusing on building the UI, or the user interface. It's the part of our application that our end users will see and use. If you've built websites in the past, you'll see some familiar stuff going on here, and you'll learn some of the complexities of interacting with blockchain applications. If you've never built a website before, that's okay too, because I'm going to explain what we'll be doing and why we need to do it. You ready? Let's get started. This is the UI we're going to be building today. We're going to make it in React, a popular JavaScript framework. We're going to build the components that you see in the user interface, and then write the code that allows the player to submit their bet and their guess to Ganache. Ganache will execute our smart contract functions and determine if the player won or lost, and depending on that, it will either keep the money the player sent or pay out the winnings for the round, and in either case, we're going to provide feedback to the user, letting them know if they've won or lost. Inside of our web app, we're going to be using React, but we're also going to be using Redux. React is a JavaScript library for building user interfaces, and React does a great job of letting us design the components that make up our application and the state that should affect them. Redux is a predictable state container. What that means is we're going to be getting a lot of data back from the Ethereum network, things like the results from every round of gameplay. When some of that information changes, we need to update the UI to let our player know about it. Redux provides a pattern to do that, and you'll learn how to use it today. Well, when you think of components, think of discrete things that make up the user interface. So our application is one big component, but it's made up of other components, like the component that shows the player's number, the component that shows the controls for placing a bet, and the component that shows the player's game history. And even that is made up of smaller components. There's the container title component and a list repeater component for each game history item. All of these have state. The history component state stores the player history. The betting window state stores the wager amount for our player and their guess, and React handles all of that. And now things are going to happen outside of our application that, number 1, need to update the state, and number 2, React needs to know that it happened and respond accordingly. Number 2 gets solved mostly because we chose React as our tool. React does a great job of tracking state, and when it changes, only updating the things on the screen that were affected by it. For number 1, updating the state, we're using Redux. In our React component, we'll do something that triggers an action, such as clicking the Let's Play button. In the case of clicking that button, it's going to call our contract using the Web3.js library and execute the win or lose function we created earlier this week. When our contract function executes, it's going to return some data, whether that's a successful response or an error message. We'll take that response and dispatch to a reducer that will update the Redux store with the new information. The updated information gets sent back to our application as props, or properties, where React can evaluate what needs to be updated in the UI. So we have a very clear separation of different pieces that make up a DApp, or decentralized application. Over here we have the Ethereum network with our contract running in an EVM, or Ethereum virtual machine, and over here we have our React application running on our web server. This part of our application can be anything. I chose a React application, but it can just as easily be an Android or iOS app, a Python application, even an old COBOL mainframe app, I guess. I mean, I wouldn't recommend that, but if you want to do it, go for it. So this part right in between here, between the React application and the Ethereum network, we're going to use a utility library called Web3.js to make that communication happen. Web3 provides utilities that allow us to communicate with Ethereum nodes like Ganache, as well as nodes on the Ethereum main and test networks. There are 4 main modules, but the ones that we're going to be working with in this course is the Web3 ETH for communicating with the blockchain and our contract, and Web3 utils for some utility functions such as converting between different denominations of Ether. Web3 allows you to use callbacks, promises, and provides event emitters to try and provide all the options you need. We're going to be using promises extensively, and I'll be covering those in detail in just a bit.